Whenever you're solving an equation, you will always put on your detective hat. You want to analyze the problem before you can solve for anything. In this case, we're going to add a few new steps. We need to find the variables you need to solve for. If needed, move the variables to the same side of the equal by adding the opposite of the smallest term. Use inverse and opposite order of operations to isolate or solve for the variable, and proceed with all of the steps that we also learned in the last lesson. Let's take a look at our notes this time. You'll see they look amazingly similar to what we've been seeing all along. We have some new vocabulary here, combining like terms, equivalent equations, properties of equality are still the same, inverse order of operations, but now we've got two new ones that are also very important to this lesson. We might have a solution where we've got infinite solutions or all real numbers. There's also a possibility of getting an equation with no solution at all. You'll see here that we are still following the same steps. Simplifying expressions will actually come into play more in the next lesson, but we need to be able to understand this so that when we solve equations, we do the opposite of everything that's we've learned about the order of operations. Let's jump into solving some problems here. On our note, it says you must move the variable terms to the same side of an equation before solving. So that's what we're going to look at here. With our detective caps on, let's take a look at the two sides of the equation. So the equal sign is right here. I'm going to draw my line through it, and you can see that I've got two variables. I've got negative 7x here, and on the left, I've got negative 10x. Now, which one is smaller? Because at the beginning of the lesson, I said move the smallest one. We do want to take into account signs. Since this is a negative 10 is actually smaller than negative 7 if you think about the number line. So I'm going to move this negative 10 by adding the opposite, which would be a positive 10, to both sides. Notice what I've done here. I actually put the plus 10x right under the minus 10x, the negative 10x. Then I put the plus 10x right underneath the negative 7x. You want to line up what we call like terms. These are like terms. All right, let's go ahead and combine them. Now we can see right here they're going to cancel. They are canceling because a negative 10x plus 10x is 0, so it's just gone. The only thing I have left over is the 7, and I'm going to bring it down. I'm going to bring the equal down the line and bring the 13 down. There's nothing to add to it. Negative 7x plus 10x is going to be 3x. Next, this becomes a problem just like we saw the last time. We can see to the x, I'm multiplying 3 and I'm adding a 13. This is a positive 13. So we want to do any addition or subtraction first. I'm going to subtract that 13 from both sides. So you can see here 7 minus 13 is negative 6. That's going to equal 3x. I can divide by 3 to get rid of that 3 that's being multiplied to the x. And it looks like my solution is going to be x equals negative 2. At this point, we could just mentally check it. So if we take a look, we've got 7 minus 10 times negative 2. So a negative 10 times a negative 2, that would make a positive 20. So it looks like over here I've got 27. Same thing, 13 minus 7, negative 7 times negative 2 would be positive 14. 13 plus 14, 27. So both sides I have a 27. You can just do mental checks. Why don't you try B on your own, and then I will show you the solution in just one moment. All right, I'm going to pick up the pace with B this time. there's my equal sign. I can see I've got the 4r on this side, the 8r on this side. 4r is smaller. So I'm going to subtract 4r from both sides. On the left, that will cancel. And I just bring down that -1, bring down the equal. 8 minus 4 is 4. Now, the reason why I always move the smaller one is this way I'll always get a positive number. We want to avoid negatives as much as possible. So I can see in this one, I've got 4 times r plus 3. So always move the addition or subtraction first. Subtract the 3 from both sides. That will cancel. And this time, I've got -4 equals 4r. Divide both sides by 4. And it looks like r equals -1. You can do a mental check to make sure that is correct. Now, C and D are very unique problems. We can see that I've got the equal here, but I've got this P on both sides. So when I subtract P, something really strange happens. The P will cancel out on both sides, and I'm left with 1 equals -7. We have a problem here because that is not true. 1 does not equal -7. Whenever you get a false statement like this, this means that there is no solution to this problem. There's no way we can ever get this equation to be equal to itself. D is very similar. For example, D, we've got the 5v on both sides. You can see this is going to happen whenever you have the same variable on both sides of your equal. So 5v cancels out on both sides. But this time, I don't get a false statement. I get a true statement. 1 is equal to 1. Whenever that happens, it means there are infinite solutions. And that is actually all there is for lesson 2.5.